Today we're going to talk about another type of transformation called rotations. So these are also going to be figures that are on a graph that you can turn clockwise or counterclockwise, but keeps the figure congruent. So the first thing that we need to talk about with rotations is that you can turn an object either clockwise. So we can either rotate objects in a clockwise rotation, or we can rotate objects in a counterclockwise rotation. So clockwise can be abbreviated with CW, and counterclockwise can be abbreviated with CC. In order to rotate an object, you have to know the 2 D's of the rotation. So if you want to rotate something, you need to know the direction, and you also need to know if it's counterclockwise or clockwise. And you need to know the degrees, so the degree of the direction. In these transformations with rotations, we are going to be doing 90 degrees, 180 degrees, 270 degrees, and 360. Okay, something else that you need to know about rotations is that after the rotation has been performed, the image is always going to be congruent, because the only thing that you're doing is turning the shape on a graph. So it's congruent because the shape is being turned and it stays the same. Okay, so if we look at the example with these letters of rotating them, if we took T and we wanted to rotate clockwise, and we rotated this T clockwise by 90 degrees, the T would now be in this position. Okay, and this would be at 90 degrees. If we took the blue T from its original position and we rotated it 180 degrees, it would now be in this position. And if you notice, it also kind of looks like it's being reflected. Now from the original T, if we rotated it clockwise by 270, the T would be in this position. And then if we rotate it back to the point that it starts at, it would be 360. So if we do the same thing for the letter H, but instead we're now rotating counterclockwise, that means that we would take H and we would move it to the left. Okay, so that would be at 90 degrees counterclockwise. So if we took our original H and we moved it 180 degrees counterclockwise, then it would be below. And as you can see, it also looks like it's reflected. If we took the original H and we moved it counterclockwise by 270, it would be in this position. And then if we went from the original all the way around back to its original position, this would be 360. And since we're moving it left, that's counterclockwise. As our T shape, we were moving it clockwise. Okay, so now we're actually going to look at a shape or a figure on the graph that has been plotted out. And we're going to take this triangle ABC and we're going to rotate ABC 90 degrees counterclockwise. Okay? And notice like the 90 degrees is basically like an L shape. So that's 90 degrees and it looks like an L. And we're going to rotate this counterclockwise. So we're going to move each point. We're going to move each point on our graph left, but then in a 90-degree motion. So we would be moving it left. So if you visualize this, and you can do this with a sheet of paper as well, but if you visualize like taking a corner of your paper and placing it or having something at a 90-degree angle, where the 90-degree angle is in the shape of an L, but the 90-degree angle passes through the origin, because that's what we're rotating. So the 90-degree angle passes through the origin, and you can just visualize this like as if it was like a sheet of paper that we cut off. Then you can see that this A, if we're rotating it around the origin at the point, this point A would now be over here, because we are taking it from point A and we're moving it around. So its new coordinates are going to be right here. Okay, and that's how you have to visualize moving each point. So our new point would be A prime. Because every time we move a figure, we have to remember to put the prime symbol. So if I did that same process with B, and I kind of visualized it, which I can go ahead and erase my little pretend sheet of paper or my 90-degree angle, because I already have my point plotted. So if I did the same thing for B, and I pictured from the origin and pictured an L shape or a 90-degree shape, and I kind of just drew or traced a corner sheet of paper, moving from this B in a 90 degrees counterclockwise around this origin, I would end up at this point right here. So this B would be moved in a counterclockwise direction to the left, and the new coordinate would be B prime. And then I can go ahead and erase my little L shape because I don't need it anymore because I just plotted the point. But the same thing for C, you can just visualize having a corner sheet of paper from the point C. If you lined up the corner of the sheet of paper with the origin, and it touched one point, your 90-degree angle would put C in this position. So it'd be turned, and that's what its new coordinates would be. So now I have my new triangle. So I'm going to go ahead and write the coordinates down for my original triangle. So this was A was at 1, 4. B is at 5, 2. And C was at 0, 2. So we can go ahead and write down our coordinates for both the triangles. Okay, so then we have coordinate A prime, B prime, and C prime. Now if you notice on these coordinates, when you compare them, if you're comparing the original to the new, you can see that for each of these, when you compare the original to the new, they have the same numbers. They're just in different positions. Same numbers, 2 and 0, and then it becomes 0, 2. Okay, the same numbers, but they're in different positions, and the sign of the Y changes. So the rule for this is that if you are rotating something counterclockwise 90 degrees, then you're taking the X and Y from the original and you are just swapping the X and Y. So you switch X and Y and then change the sign on the Y. Okay, and we formally write that when we say that we're switching the X and Y, is like our original coordinates were X and Y. That's all of these up top. And we converted them by switching X and Y, but changing the sign on the Y. So we represent changing the sign on the Y by putting a negative, even though it's not changing to a negative. This just represents change the sign. So in the rules, this just means change the sign. So if you have a coordinate that was originally like 1, 2, your coordinate would now become 2, 1, because you would switch the X and Y, and you would make this negative. But say you had another coordinate that was -1, -2. Well, the rule is change the sign for Y and swap X and Y. So I would swap X and Y, and I'm going to change the sign on the Y. So now it's going to be positive. So that's how you would do your coordinates. Okay, now we have to go and rotate the original triangle, which had the coordinates for A, B, and C. So we know that A was 1, 4, B was 5, 2, and C was 2, 0. Okay, and we're going to take those and we're going to rotate counterclockwise 180 degrees. So you have to think about this. When we did 90 degrees, we visualized a corner because corners have 90 degrees. Well, 180 degrees, we can visualize a straight line. Okay, so that would be a straight line from A that goes through the origin and it's just a straight line. So it's basically just a straight line from A to A prime prime. So you have a straight line. So our new point for A would be right here. Okay, you can also look at this like moving it counterclockwise 90 degrees twice. Okay, so the new coordinates for B would be at, if you were going through the origin to B, you did a straight line, which you would have to use a ruler with, then your new coordinates would end up right here for B. So that would be B prime prime. And the same thing with C. If I was going to draw a straight line from the origin to C, okay, you have to make sure it has the same amount of distance too. C would now be over here, and that would be C prime prime. So now we can connect our points to make the triangle, and then we can go ahead and write our new coordinates. So A prime prime, we'd have -1, -4. B prime prime, we'd have -5, -2. C prime prime, we would have -2 and 0 because we can't change the sign on a 0. So if we're comparing these two, if you look at the original to the new coordinates, you can see that the position of X and Y stay the same. The only difference is that the sign changes. So if this was our original X and Y up here, these are all of our original coordinates, then the change would be that we kept X and Y in the same position, but we made both of the coordinates opposite. So both coordinates are now opposite. So we're going to keep X and Y the same, but then both coordinates are now opposite. So that just means they have the opposite sign. So far, you can see that from this point A, okay, and we're looking at this from the origin. So we have this point A, and we moved it counterclockwise 90 degrees. So then we went to this point A, okay, and then we moved it again to this point A, so, and then that's from the origin. So you can start to see it kind of rotate in a circle. So now to get the original figure to rotate from A all the way around to 270, we know that we just have to make another 90-degree turn from 180. So if we make another 90-degree turn, then A should be so we should have A turning 90 degrees clockwise, because that's the same thing as going 270 counterclockwise. So our new coordinate for A, if we brought this around, so this is 190 degrees, 290 degrees, which makes 180, and then 390 degrees, which makes 270. So our new position for the coordinate for A prime 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 would be right here. So with B, you would look at it the same way, okay, through the origin. And so B would now be, if we drew our L shape, it would now be down here. So this would be B prime prime. And then if we did the same thing with C, C would now be down here. So it's prime, prime, prime. Now we can connect those points for our new triangle. Okay, so the new coordinates for A prime, 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 you have to be sure that you put that, because that represents how many moves you made. So the new coordinates would be, A would be at 4, -1. B prime prime would be at 2, -5. And then C would be at 0, -2. So if you look at from all of our originals to all of our new, the coordinate, like 1, 4, is flipped. So now it's 4, -1. So you go from having your regular x, y. The rule for this is that you flip the position, so now you have y coming first, then you have x. And then you can see that from 4 and 1, the only sign that was changed was on the x, so we have to change the sign of the x. So we're going to change the sign of the x, and that's the rule. So you switch x and y and change the sign of the x. And that is the rule for rotating at 270 counterclockwise. So now we're going to organize our results from our graph, and then we're also going to write the rule above. So if you're going to rotate something counterclockwise by 90 degrees, okay, the rule is that you're going to start with your x, y, and you take your coordinates, and if you're going to rotate them 90 degrees, then your rule is that you're going to switch the x and the y, and that you would just change the sign on your y. Okay, that's basically saying that if we're starting A at 1, 4, if we're going to switch the x and y, then 4 would come first, and then we change the sign of the x. Oops, I did that, messed that up. Okay, so 4 would come first, then 1, and we're going to change the sign of the y. Sorry about that. Okay, so for the next set of coordinates, you're just going to switch them and change the sign of the y. The next one, you're just going to switch them from 2, 0 to 0, 2 and change the sign of the y. But it's a 0, so we can't change it, sign. Okay, the rule for rotating something 180 degrees is that you're going to take your original coordinates and then you're just going to write the opposite signs for each of them, so that they stay in the same position. So we go from 1, 4 to negative 1, negative 4. We go from 5, 2 to negative 5, negative 2. We go from 2, 0 just to negative 2, and then 0. And then with 270, you are going to switch the signs, but instead of making y negative, you're going to make x now with the negative or opposite sign. So you'll switch the coordinates, so you go from 1, 4, and you're now going to put 4, 1, and make that one negative. Then this one you're going to go from 5, 2 to 2, 5. You're going to make the x negative. Okay, and if you want to go 360, that's basically just writing your original coordinates. So if your original coordinates were 1, 4, they'd still be 1, 4. They were 5, 2, they'd still be 5, 2. They were 2, 0, they'd still be 2, 0. So those were the rules for counterclockwise. Okay, so for number 3, if you did clockwise, so clockwise has kind of the opposite rules. So clockwise versus counterclockwise, for the 180 rotation, for clockwise and counterclockwise, the 180 is the xy coordinates are just going to be the opposite sign, but they stay in the same position. So this is clockwise. For 90 is going to be the same as 270 counterclockwise. So your y and x are going to switch positions, and your x is going to change signs. And then for 270 rotation, and this is going clockwise again, your y and your x are going to change, but the y is going to have the opposite sign. And then for 360, you're just going to keep the same coordinates. So this is clockwise. But if we did counterclockwise, and we did 90 counterclockwise would be the same as 270 clockwise. So the y would be opposite sign, and then you'd have x. The 180 is just the opposite sign. And then the 90 clockwise is going to be the same as 270 counterclockwise. And those are the rules. And those help you too. The easiest rule to remember is the 180, because all you're doing is you're keeping it in the same position, the x and the y, and you're just changing the signs. Okay, so if we look at number 4, it says, what are the coordinates of 3, -2 under a 90-degree counterclockwise rotation? So 90 degrees counterclockwise, as you guys can remember, so counterclockwise is the same as 270 clockwise. So we're going to take these coordinates and just switch them, switch positions. So now 2 would be over here and 3 would be over here. And then we're going to change the sign on the y. So now it's positive. And that's all you do. So you went from 3, -2 for a coordinate to 2, 3. So the next one is, what are the coordinates of -5, 4 under 180? So with 180, it doesn't matter if it's counterclockwise or clockwise, you're always just going to switch the sign. So that's a -5, so now it becomes positive, and this is a +4, so now that becomes negative, and that's my new coordinate. And then number 6 says, what are the coordinates 3, 2 under a 90 degrees clockwise rotation? So clockwise is the same as 270 counterclockwise. So all you're going to do is switch the position of x and y. So now we're going to put 2 first, then 3, and then we're going to change the sign on the x. So your new coordinates are 2 and -3. So I hope this gave you some reinforcement for today's rotation lesson.